Hi guys, my name is Terry. In this video, I'm going to go through with you the additional mathematics Form 5 textbook question for Chapter 8, Kinematics of Linear Motion, Formative Exercise 8.1. Right? If you enjoy this video, can you like, subscribe, or leave us a comment? All right, let's go straight to the first question. Okay, so here we have the mud deposited on the river bed that makes a river run through a village. And then this makes the boat traveling in and out difficult. The boat move along a jetty in a straight line, and is given by this displacement function s equals to t squared minus 4t. So you're supposed to copy and complete the table. Now we can calculate one by one manually, yeah, by taking your calculator, use your calculator, basically sub 1 there, 1 square minus 4 times 1, which gives us -3. All right. Then you take 2 square, which is 4, 4 minus 4 times 2, which gives us -4, right? And then 3 square 9, 9 minus 4 times 3, which 9 minus 4 times 3, 4, 9 minus 12, -3. And if I put 4 inside, 4 square is 16. 16 minus 4 times 4, which gives us 0. Lastly, if I put 5, 5 square is 25. 25 minus 4 times 5, which is 20. 25 minus 20, you get 5. Yeah, we can do it that way. You can also use your calculator. Now, here I'm going to show you how to use your calculator. Yeah, in your calculator, depending on what model you're using, if you're using this 570, this ES plus, so we can actually use mode 7 for table, right? You can key in the function. The function is y equals to, in this case, we use fx equals to x squared minus 4x. We can use this button here, alpha x, and then square it, that's x squared. Then you minus 4 times alpha x again. Oops, sorry, 4 alpha x. And then you press equals. All right. Now ignore the second function, you just press equals. Where do you start? You start from 1. Where do you end? You end with 5. And what is the step? The step is 1, because the step is the difference between each t value here. So you press equals, there you go. And you see, you can generate the whole table straight away. Yeah? First one is -3, second one is -4, next one is -3 again, then 0 and 5. Okay, so fairly simple. Okay, next we're going to sketch the displacement time graph. Okay, so maybe I move this up a little bit, right? So yeah, I need to squeeze this in. So let's just up a bit, up a little bit. Okay. So let me just copy this -3, -4, -3, 0, 5. But actually, you don't need all this value to draw the graph. When it comes to sketching graph, right? So what is important is the turning point, the intercept, right? Or the domain given. So here they didn't ask us exactly what is the domain. So they didn't mention. So we can just draw or sketch like this, horizontal and vertical. Yeah, looks like this. No, I know I have to start from 0, because when you start the clock, t is 0. So this is your displacement. Now, we can see if I put 0 inside, the whole thing is 0, right? Yeah, mentally you can start inside 0, 0. And we know this is a quadratic, it must be a smiley face graph. Okay, so it should go like this. Okay, all right, looks a bit ugly. Okay, let me draw like this. This is better. It looks still a little bit ugly, a bit lower, a bit higher. Okay, no, not very nice, but I think this is all right. Okay, I'm going to start off by putting in this one. I know this is 4. You can use the table here that we already gotten earlier. Right? We know this represents your x-intercept, in this case, t-intercept, t-axis. So, and then you know that your axis of symmetry must be in the middle. 0 plus 4 divided by 2, this is 2, which I'll have it here. The y value or the s value is -4. And when s equals to 5, your s value is 5. Yeah, so this one is displacement in meter, this is time in second. All right, so there you go, that's your displacement time. You don't have to put the rest of the point. When it comes to graph sketching, just show the important points. In this case, it will be 0, 2, 4, and even 5. Okay, because 5 is the last one that we have here. Now, find the time in second when the boat is at the jetty again. Now, because S is actually the reference point from the jetty, right? So when we say the boat returns to jetty, it has to be when the displacement goes back to 0. Yeah. So when your displacement S is 0, what is the time? T is 4, right? There you go. That's your answer. Okay, let's move on to question number 2. All right. Now, Shaza cycles a 3-wheel bicycle, right? And in a straight line. Let me move down a little bit more space. All right, in a straight line at her house backyard, and initial displacement is 2 meters from the flower pot. Her displacement after passing through the flower pot is given by this function. Determine the value of C. Okay, we know that when you start the clock, E is 0. Okay, all right. Initial displacement is 2. So we can just sub inside here. Yeah, sub E with 0, S with 2. So S is 2. This is 0, power 3. You don't have to write all this. 2 times 0 plus C. So my C is just 2. So my displacement function is D power 3 plus 2D plus 2. Yeah, simple. Now then find the distance of Shaza from the flower pot when T is 2. When T is 2, just sub inside 2 power 3 plus 2 times 2 plus 2 here. So this is 8 plus 4, 12. 12 plus 2, 14 meters. Okay, find the distance of Shaza from the flower pot when T is 3. Well, when T is 3, just put 3 inside. 3 power 3 plus 2 times 3 plus 2, 27 plus 6, 33, 33 plus 2, 35 meters. Right. Okay, let's move on to question number 3. All right. So a particle moves along a straight line from a fixed point O. A displacement is given by this function. Calculate the instantaneous displacement when T is 0 and T is 10. Very simple. Instantaneous displacement means displacement at that point in time. That means sub T with 0. What's the displacement? Put 0 inside. The whole thing will be 0. 3 times 0 plus 2 times 0 is still 0. So there you go. Answer is 0. Now, when T equals to 10, you put 10 inside. 3, 10 squared, 2 times 10. So this is 300 plus 20. Answer 320 meters. Okay, also that is simple. Now, next one, question number 4. Diagram shows a boy kicking a ball, yeah, in the field. The ball moves in a straight line, passes through fixed point marked P. So at T second after passing through P, the velocity is given by this V equals 7T minus 5. Find the instantaneous velocity at these two time. T equals to 2. Instantaneous velocity simply means the velocity at that instant. So we just put 2 inside. This is 7 times 2, 14. 14 minus 5 is just 9. So it's 9 meters per second. When T equals to 4, your V is 7 times 4 minus 5. 7 times 4 is 28. 28 minus 5, 23 meters per second. Okay, question number 5. Okay, so a particle moves along a straight line. Its acceleration is given by this function, 4 minus 2t. Find the initial acceleration. Initial acceleration happens when t is 0. So you're going to put 0 inside. So 2 times 0 is still 0. Your acceleration is 4 meters per second minus 2. Determine the range of time in second when the velocity is decreasing. Now, when the velocity is decreasing, your a is less than 0. When your velocity is increasing, your a is more than 0. So we're going to take 4 minus 2t, that will be less than 0. Well, you can bring the 4 over, so it's less than minus 4. And every time you times or divide with negative, please change the symbol. Minus 4 divided by minus 2 is positive 2. 2t is greater than 2 seconds. Now, you don't want to put a unit, it's okay. Yeah? So that's the range of values of t. Okay, number 1. All right, moving on to Number 6. The particle move along a straight line. The fixed point from fixed point O, the displacement is given by this function. Find the displacement when t is 3. Okay, when your t is 3, your displacement is 2, 3 squared plus 3. This is 9. 9 times 2 is 18. 18 plus 3 is 21 meter. Now, find the total distance traveled in the first 5 seconds. So one thing you need to be sure, because sometimes the particle may make a U-turn, right? If the particle makes a U-turn, then you need to consider the distance, total distance traveled. You have to consider the time when it changes direction. Now, since this question is quite how do I say, quite a simple graph, we can actually do a sketch. Just want to show you this. If you let S be 0, you will get 2t squared plus t equals 0. So I factorize the t, 2t plus 1. Now, this is actually not necessary. I just want to let you know the roots are negative, half, and 0. That means that if I were to sketch this graph, it actually falls on the left-hand side, like this. This is S versus t, and this is your negative 1/2. This is 0. So the particle doesn't actually change direction, right? So it starts from point O, it just go all the way up. So we don't have to worry about the particle changes direction. So to find the distance traveled in the first 5 seconds, basically we just sub t with 5, find this value, S5, right? And when t is 0, S is still 0. So yeah, you don't have to use S5 minus S0 because S0 is still 0. So, okay, let's just say I find S5 first, okay? S5, you put 2 times 5 squared plus 5. So this is 25, 25 times 2 is 50, 50 plus 5 is 55 meter. So your total distance, yeah, no need to modulus or anything. It doesn't go negative, so it's just 55 meter, right? Since it doesn't change direction, so it's quite clearly. Usually, if it's a plus, it is on the left-hand side, you can see, so it doesn't change direction. If this is a minus, then the particle may make a U-turn like this, right? So it does affect, yeah, the total distance. All right, question number 7. Oops, good job. Now, this question 7, you have to first copy the table, sketch the displacement time graph, and then calculate the total distance traveled. Okay, okay, just need to see this. This is your function e s equals t minus 2 squared plus 5. Okay, now again, I like to use you can use mentally. Let's say I do mentally. 0 minus 2 is minus 2 minus 2 squared 4, 4 plus 5 is 9. I put 1 inside. 1 minus 2 is negative 1. Negative 1 squared is 1. 1 plus 5 is 6. I put 2 inside. This whole thing becomes 0. This is 5. Now, one thing about quadratic, they're always symmetrical. You can, if you learn, remember you've done this in your form 4. A minimum is 5 and t is 2. So this is t equals 2 is an axis of symmetry. The graph is symmetrical at 2. So if you move on to 3, this will be 6. Then this will be 9. They're symmetrical. Yeah, you don't have to count, right? You can actually, you don't believe me, put 3 inside. 3 minus 2 is 1. 1 squared is 1, right? 1 plus 5 is still 6. Okay, and same goes to 4. 4 minus 2 is 2. 2 squared is 4. 4 plus 5, you still get 9. Yeah, you get exactly the same value here because they're symmetrical at t equals 2. But for 5 and 6 have to count. 5 minus 3 minus 2 is 3. 3 squared is 9. 9 plus 5 is 14. 6 minus 2 is 4. 4 squared is 16. 16 plus 5 is 21. Now, if all this mental calculation is making you dizzy, just use your calculator. Yep, I'll show you how to use a calculator. Oops, there you go. My calculator here. I'm going to press mode 7 for table. All right, so let's start off by putting in your function. Your function is, open bracket, alpha x minus 2, close bracket, square, plus 5. I'm going to press equals. Gx, we just press equals, ignore it, start from 0. Then you go and at 5, maximum is 5. And the step is 1. That step is the difference between each value. So you press equals. There you go. You got 9, 6, 5, 6, 5, 9 again, 14, and 14 is the last one. Okay. Oh, I have another one, 21 actually. So I need to put mode. It's okay. Just change the question. Just press equals. Oh, I need to add in one more. right? So press AC, press equals, equals. I should end at 6. There you go. It shows up to 6 now. Yeah, at 6 is 21. All right, sketch the displacement time graph. Okay, so when you sketch a graph, you can see here, again, we don't need to draw everything. I just show the important points only. So I'm going to show you from here to here. I know the whole thing is above the x-axis. They are all positive, you can see. So this is displacement meter. This is time in second. Okay, so it's a smiley face graph, but it starts from 9. Maximum is 21. So I'm going to put a 9 here. The lowest is 5. So it goes down and up. Okay, so just show the important point 9. This will be 5. This is at 2. And at 21, your time is 6. Right? It's a smiley face. You can draw a little bit sharper. Mine is a bit flatter, right? You can draw a bit sharper because my line here I do a bit longer. Okay, so what is the total distance traveled? You can see it from the graph. It actually goes down, yeah, or go to the left. From 9, it goes to 5. So the difference, your total distance, will be first, we take 4, because this difference here is 4. Then it goes up. From 5 to 21, the difference is 16, right? So you're going to add 16. Your total distance travel is 20 meters. All right. Okay, I hope this is not too difficult. All right. Yeah. So again, if you enjoy this video, yeah, like, subscribe. We have a lot more manual, what do you call that? Our book collection from topical practice, intensive practice, drill practice, past year question, or even our notes and tutorial series. If you're interested to get to know more about all of the books that we have, you can contact us. Find us on Shopee. Yeah. Thank you for watching this video. See you in the next one.